Our ambition at ZeroAvia is to not only develop hydrogen electric powertrains to provide zero-emission flight, but also to develop the infrastructure and ecosystem around those powertrains to allow it to be commercially adopted. And that requires solving for a couple different things. So we have to solve for the cost, we have to solve for the technical, and we have to solve for the airport operations aspects of it. We need to appeal not only to the airports, to the local municipalities, and to the airport operators, and we're developing technology which is easily permittable, which fits the operating window of our airline operators and doesn't take too much space within the existing airport ecosystem. One of the reasons why I care about trying to change aviation and bring it into zero emission is because of the technical challenges that are within this industry and some of the hurdles that we have to do. If it was easy, everybody would do it. But because it's hard, makes it all the more rewarding. So the hydrogen ecosystem is one that we're still developing in this world, and that's something where my team that I'm leading is very focused. And when we think about what the ideal version from a ZeroAvia standpoint looks like, you have co-located renewable assets which are generating green electrons. You feed those to an electrolyzer on site, and then you have a densification process which could either be compression or liquefaction to cryogenic temperatures. We store that then airside, and then we are developing key pieces of our product roadmap, which are the mobile storage and dispensing technologies. And we have one for gas, we have one for liquid. And for these two different technologies, they are the most capitally efficient way that we can take the product onto the airfield, and we're able to actually dispense it to the aircraft with minimal losses and ensure that we get as close to 100% state of charge on board the aircraft, meaning you fly the furthest you can. And we see it really broken into three different phases. There's the early phase, the mid phase, and the long-term vision of it. So when we think about the long-term vision, where we're trying to go, it's really about how do we make hydrogen a fungible commodity like what we see with gasoline, diesel, and jet fuel. In the mid phase, we see liquid becoming very much more prevalent and accessible in a more centralized model. And when we come to where we are today, it's about how do we develop entry into service, because currently you go to any airport in America, there's not hydrogen on site. So we're developing products within our infrastructure product roadmap, such as our mobile storage and dispensers, which are most capitally efficient to be able to bring that molecule airside, store it, and then distribute it to the aircraft to enable zero-emission flight. The airport of the future to the customer looks the exact same. However, behind the scenes, things are bustling. So we see that hydrogen will actually be produced on site, which is a complete turn of the head of the industry today. So currently jet fuel is brought in via pipeline, truck, whatever the mode of transit, but it's the single largest OpEx that an airport has. We see hydrogen being produced on site from green electrons that are collected there, and that can turn the single largest OpEx into a revenue generator. When we think about the communities who are impacted most by airports, the local surrounding, the emissions and the noise are both reduced, if not fully abated. And that's something where airports can now become more of a joining force within communities.